First, we look at if and unless. The if control structure is likely very familiar to you from Java. It starts by if followed by the condition. Remember that the condition can be any value, and false and nil are the only falsy values. So everything else is a truthy value. This is followed by an expression. This is the expression being evaluated if the condition 1 here is true. If the condition 1 isn't true, we can test against another condition, condition 2, and this is done with else if. And if that condition is true, we will evaluate E2. And we can have a whole sequence of else if conditions. And then finally, as a fall through, if you will, we can have an else condition. If none of the conditions 1 through n is true, we will evaluate expression en plus 1 here. And of course, the if control structure is framed by if and and. There are multiple different ways of writing if conditions. So you can write if condition then and. In shorthand, you can have the same effect if you write if condition semicolon and end. This allows you to write both the condition and the expression you want to evaluate if the condition is true on a single line. Let's look at a simple example. We're specifying the factorial function here with a helper function. So fhelp is the helper function, and it accepts two parameters, the current value of n and an accumulator. And so we're now using the if control structure to test whether n is less than 0. If that is the case, we evaluate this expression here, and what it does is to raise an exception. And if the exception is raised, we can see the string we supply to the raise method. Assuming n is at least 0, we can test whether n is at most 1. If that is the case, we return the value of the accumulator. Otherwise, in all other cases, we call fhelp again with the predecessor of n, so this evaluates to n minus 1, and the second parameter is n times the accumulator, so we multiply the current value of the accumulator with n, and this then becomes the new accumulator in the recursive call. And of course, to complete the definition of the factorial function, we give the definition here. Factorial of n is defined by a call of fhelp with n and the accumulator initialized to 1. I have entered the definition of function fhelp into the IRB, and we can try it out. If we supply fhelp with a negative first parameter and an arbitrary second parameter, we would expect the exception to be raised, and in fact it is, and see that it prints the string we actually supplied by calling the raise method above. We can now supply a different value for n. Let's say we go with 0 and an arbitrary second value, 42 here. And then, as we would expect, the return value is the second parameter, ac in this case. And finally, if we call fhelp with let's say 3 and 1, then we would expect 6 because we actually calculate the factorial function for the parameter 3. If you find yourself writing negative condition often, such as if not something, Ruby offers a shorthand for this called unless. So this says unless the condition holds execute E1, else execute E2. And this is useful as shown in the following example. We say unless the person is authorized, we raise an exception. And this is equivalent to saying if the person is not authorized, we raise the exception. It's worthwhile to understand that control structures in Ruby are in fact expressions, so they can be used anywhere where an expression is allowed. So let's say I'm creating 2 local variables here. A is initialized with 10 and B is initialized with 20. And then I use a puts to print a certain string, and the string here is the maximum of A and B equals, and now I'm using string interpolation, and the expression I'm interpolating into the string is an if expression. And this if expression returns the value of A or the value of B, depending on which one is the maximum.